If you strap a wad of wet dirt and plastic around a live tree branch, the tree will respond and grow an entire secondary root system, right in the sky. But how do you trick a branch into sprouting roots while it stays suspended in midair? Trees grown from seed take 5 to 10 years to reach sexual maturity, leaving you waiting a decade for your first harvest. We are skipping that wait entirely. To understand how this works, you have to look at the biological plumbing inside the wood. We are intentionally breaking the transport system. A tree branch operates like a two-way biological highway. The inner woody tissue, called the xylem, acts as the northbound lanes, pulling water up from the ground to the leaves. The outer vascular tubes, called the phloem, act as the southbound lanes, carrying sugar down from the leaves to the roots. When you slice away a ring of bark, you completely sever those outer southbound tubes, but you leave the inner wood intact. The branch is still actively pumping water up, keeping the leaves hydrated, but nothing can travel back down. Because the downward flow is blocked, sugars and rooting hormones, called auxins, which act like chemical construction foremen, pool at the upper cut edge. This creates a massive traffic jam of rooting hormones trapped right at the edge of a cliff. Trapped and pooling, these hormones force the plant to scab over with a callus and eventually push out adventitious roots that sprout directly from a stem instead of the base. You are actively weaponizing the plant's own chemical signals to do the heavy lifting for you. This technique is called marcotting. It was pioneered centuries ago by the Chinese to propagate difficult-to-root plants like lychee and citrus trees. You are using a resilient, low-tech historical method proven to work for centuries before garden centers ever existed. But picking your target is critical. We always select a branch from a mature, fruit-bearing section of the tree, but never attempt this on a branch that is actively holding fruit. If you do, the tree will stubbornly divert all its energy into growing that fruit and totally abandon the root-building process. You will waste months of your time and often lead to an empty harvest. Now we perform the surgery. We slice away an inch-wide ring of bark to expose the inner wood. You have to peel the branch exactly right, or the tree will simply heal the wound, like a scraped knee. Right under the bark sits the cambial layer, a microscopic sheet of stem cells that feels like the slimy membrane under an onion skin. You must aggressively scrape this slippery green tissue away with a knife until you are left with a ring of naked white wood on a green branch. If you leave even a microscopic strip of that slime, the tree will simply build bridge tissue. It will form a skin graft to bypass your roadblock, reconnecting the nutrient flow and refusing to grow a single root. You want total separation. As the branch remains attached and continues to receive water and nutrients, the mother tree acts like a life support system, keeping a patient hooked up to an IV drip while they recover. This trick allows you to clone massive branches that would quickly die if you just snapped them off and stuck them in the dirt. But those new roots need both oxygen and water to survive. Picking the wrong dirt here will drown the system. We pack the wound tightly in sphagnum peat moss, a fluffy botanical sponge that holds incredible amounts of water without suffocating the fragile new roots. We want a baseball-sized wad of dripping wet moss wrapped securely around the cut. Centuries ago, growers had to constantly hand water the moss because developing roots desiccate without constant high humidity. Today, we wrap it tightly in polyethylene film, which is just ordinary plastic wrap. This traps the humidity to create a hands-off incubator. Adding 2 cents worth of plastic wrap turns an incredibly tedious historical chore into a zero-maintenance closed loop. After several weeks, the magic happens. You will see thick roots spiraling inside a plastic wrap cocoon. The bag is filled with vigorous roots. Now it is time to sever the clone. Slicing an entire root system off the mother trunk is a massive shock. Even after the roots grow perfectly, there is one fatal mistake that will kill your new clone the moment you cut it free. When you make the final cut, you are left with a tiny root ball supporting a giant leafy canopy. The new roots cannot absorb enough water to sustain all those large leaves. It is like trying to drain an Olympic pool through a single drinking straw. This causes severe transplant shock, starving the plant. You must perform significant leaf pruning upon detachment. Skipping this final pruning step can be fatal to your perfect clone right at the finish line. Cut the leaves back, then plant and heavily water the root ball. Deciduous limits. If you want to build self-reliant systems, we map them out every week. There is one biological catch to this entire process. This method is incredibly effective for tropical and subtropical fruits like citrus and mango. But it is highly unreliable for deciduous fruit trees, the ones that hibernate and drop their leaves in winter, like apples and peaches. Those trees resist air layering and require grafting, where you splice a branch onto a different tree's root system. The historical name for this trick, marcotting, comes from the French word marcotte, which historically referred to a shoot or twig bent to the earth to take root. We flip the script by bringing the dirt up to the branch. You now have a clone that is ontogenetically mature, biologically acting like an adult plant. It skipped the multi-year juvenile phase and jumped straight into the workforce. Instead of waiting 5 to 10 years for a seed to reach sexual maturity, this clone produces fruit in 1 to 3 years. To feed your new clone using 0 synthetic fertilizers, you need an independent nutrient supply. Watch our breakdown of a closed-loop aquaponics system next, where fish waste powers massive plant growth. Nature provides the chemical tools required to bypass years of waiting. You just have to know where to cut. Stop wasting a decade on seeds. Skip the garden center completely and build your own independent system. If you liked this, 7 ways to stop garden pests without pesticides or chemicals, that's the next one.